Welcome back, recruits, to Phase 3 of AP Calculus Bootcamp. Your clearance has been verified. Today's mission is Operation Complex Differentiation, covering Unit 3, Topics 3.1 through 3.4. This intelligence is classified Recruit Eyes Only. Let's begin. Here is your situation report on escalating threats. In previous phases, you engaged basic, clean targets like y equal x squared, where standard power, product, and quotient rules apply. Now you will face composite and entangled targets, functions hidden inside other functions, and variables mixed together in a single equation. Be advised, your basic rules are insufficient here. Advanced protocols are required. We begin with target identification for composite functions. To safely dismantle a composite target like y equals cosine of 3x squared, you must first identify its defensive layers. You have the outer shell, which in this case is the cosine function, and the inner payload, which is the 3x squared. To penetrate these layers, we deploy our standard operating procedure, the chain rule. Using Leibniz intel, this means dy dx is achieved by multiplying dy du by du dx. But out in the field, you must memorize this primary directive, the mantra, take the derivative of the outside, applied to what's inside, times the derivative of what's inside. Be on high alert for these high-risk targets. First, the hidden power, like sine squared of x. Protocol dictates you rewrite this with outer brackets before executing the power rule, followed by the trig derivative. Second, the e target. Remember that for e to the x squared, the exponent itself is the inner payload. Finally, the variable switch. Do not get tripped up if command uses a t instead of an x. Execute your protocols normally. We are now executing a tactical shift to identify entanglement. Explicit targets are static and clean, y is isolated, and direct differentiation is authorized. Implicit targets are entangled, such as x squared times 3y squared plus y is equal to 10. The variables are compromised, and y cannot be easily isolated. In this scenario, implicit protocols are required. Here is your execution checklist for implicit protocols. Step 1. Differentiate both sides with respect to x. Step 2. Isolate all terms containing dy dx on one side of the equation. Step 3. Factor out the dy dx. Step 4. Divide to extract the final target. Critical intel, y, is a function of x in disguise. Every single time you differentiate a y term, you must attach dy dx via the chain rule. We now move to special ops inverse functions. This is the ultimate mirror maneuver. If f of x and its inverse are in play, remember the locational shift. A point a comma b on the original function becomes point b comma a on the inverse. Because of this, their slopes are mathematically locked together. Let's look at the visual recon for this reciprocal connection. If the target f of x has a slope of m at coordinate a comma b, then the inverse function at coordinate b comma a has a slope of 1 over m. Mission critical note, the slope of the inverse is the exact reciprocal of the slope of the original function. Danger. Do not confuse the inverse notation with a reciprocal fraction. This is your arsenal for inverse trig targets. Memorize these base weapon protocols for arcsine, arctangent, and arcsecant. Pro tip. Just like your standard trig rules, any cofunction, like arccosine, arccotangent, and arccosecant, simply deploys a negative sign to these exact same base formulas. Declassified intel, the master key. Do not memorize Phase 3 as isolated rules. Look at the underlying architecture. Implicit differentiation is just the chain rule applied to an unknown inner function y. Inverse derivatives are derived entirely by applying the chain rule to the identity f of f inverse of x is equal to x. Conclusion: the chain rule is the engine powering all Phase 3 operations. Situational awareness requires multi-source intel. The AP exam rarely relies solely on clean algebra. You must be able to execute Phase 3 rules using raw data. This means extracting precise coordinate values from numerical tables, identifying tangent line slopes from visual graphs, and executing standard protocols on analytic equations. Fluency across all three is a strict mission requirement. Keep these rules of engagement in mind for AP exam survival. 1. Order of operations. If multiple rules apply, step back. The outermost mathematical structure dictates your first move. 2. Don't drop the chain. Forgetting to multiply by the inner derivative is the #1 cause of mission failure. 3. Identify your a and b carefully when working with inverse derivatives. After action report. Phase 3 debrief. 1. The chain rule dismantles composite functions from the outside in. 2. Implicit equations require tagging every y derivative with dy dx. 3. Inverse function derivatives rely on reciprocal slopes at swapped coordinates. 4. Fluency in graphs, tables, and algebraic equations is non-negotiable. Mission accomplished. Next phase. Contextual applications. Status. Dismissed. For more AP Calculus worked out free response question solutions, like and subscribe to get your FRQ on.